We're here to discuss various issues. We're here to answer questions, to help you learn, to help you with difficulties, whatever we can do to demystify and enhance amateur radio usage. And we hope to do that by choosing topics, but also being open to answering questions as well. So we welcome your questions. We welcome opinions. We ask that everything be shared in a respectful manner that respects everybody that's listening and at their various understanding levels. I will begin this evening by taking check-ins because I would like to see who is here and who is able to answer questions and who might have questions. So as you check in, if you would please give me your call sign phonetically, and if you have a question, state that, just indicate that you have a question as you check in. Don't be in a hurry to check in because you know we're going to have doubles. I'll take several check-ins and I'll come back and repeat and check in with everybody. So let's go ahead and have check-ins at this time.
Kilo Echo 0, Oscar X-Ray Victor. Scott checking in. Good evening, Kevin.
This is November 0, November Yankee Yankee, Bart in Evans. I have no questions.
Kilo 0, Alpha Bravo Kilo. Alec, LaSalle, just gonna be listening in the background. This is Kilo Echo 0, Lima Charlie Kilo, KE0LCK, the other Mike from Windsor with a comment.
Good evening to Kevin and the Net. This is Whiskey 0 Delta Delta Zulu Dave and Greeley.
Okay, let's hold up and let me go through because I know I missed at least one. W0DDZ, welcome. KE0LCK with a comment. I'll come back to you. Thank you. There was somebody that checked in along with him that started to check in just before Mike got in there. And K0ABK, N0NYY, and KE0OXV. Thank you all very much. All right, who did I miss? Who doubled first before anybody else comes in?
Kilo Echo 0, Quebec Charlie Romeo, Robert Mobile. No questions, just sit in and listen.
Okay. Thank you, Robert. KE0QCR. Thank you for joining us. Other check-ins tonight, please.
This is Whiskey 0, Romeo Delta Charlie, Rob, around Owl Canyon. This is November 0, Echo Mike Papa, Greg, Fort Collins.
November 0, Bravo, November Kilo. Rick, Fort Collins.
This is Kilo Echo 0, Papa Tango Echo, Mike in Fort Collins.
Okay. Welcome to KE0PTE, N0BNK. Good evening, Rick. N0EMP. Good evening, Greg. W0RDC. Good evening, Rob. Anybody else at this time?
This is Kilo Delta Zero, Whiskey Bravo Charlie Pete Fort Collins.
Good evening, Kevin. This is Whiskey 0, Alpha Sierra Papa, Terry, Berthoud, Charcoal Grill Portable. N0NYY with a relay.
Relay, go ahead, please.
She can't grab the microphone at the moment. November 0, Quebec, X-Ray, Quebec, has her hands full but wants to check in. Thank you.
Okay. Let's welcome N0QXQ, Gene, W0ASP, Terry, KD0WBC, Pete. Thanks much. I think we may have missed somebody else, so please come again. Okay, anybody else wanting to check in before we start?
KB0, SCX, George and Berthoud.
Okay. Good evening, George. Glad to have you with us, KB0STX. Thanks. Let's go ahead and get started, and if we have additional check-ins, we'll be glad to welcome them as we go along here. LCK, I think you had a comment for us.
Thank you, Kevin. This is KE0LCK. While we're on the subject of antennas, I had the opportunity today to get some technical assistance from Greg, N0EMP, who provided an antenna at a fantastic location at about 7,500 feet elevation that allowed me to get in contact with Bill, KC8WSM in Cheyenne, to get my 50th state for FT8, 20 meters. And I also wanted to thank a couple other people, like there's a guy up in Basin, Jerry, WB7S, one of our members, WY7AA, RJ Bragg, who has assisted me, and just a number of other people that allowed me to finally get it today. And Greg was extremely helpful, and I thank you, bud.
Okay. Congratulations. I'm so glad you finally got that. You've been waiting a long time for that. So, and congratulations on all the 50 states there. That's terrific. Yep, hams helping hams. I think that's always a very important thing. And, appreciate the assistance. And sounds like, Greg, that new property is coming in handy for lots of things there. So, glad you got that, Mike, and thanks for the report. Okay, I had no questions posed while we were checking in, but hopefully the subject we propose here will generate some questions. It was suggested we chat a bit about antenna supports, towers, poles, trees, types of towers, crank up, roll, tilt over, other supports. Lots of various things there. I think I will just kind of pick and choose just a little bit arbitrarily here from folks that I know have been doing this before to see comments from people. Greg, you okay if I pick on you first, N0EMP, and just see what you might like to share about various antenna supports?
Sure, Kevin. I'd have no problem with that at all. Let me make sure I've got this. So my primary interest in radio is systems that aren't necessarily portable, but they're at least transportable, that in a relatively short period of time, without a lot of effort, one or two people can break a system down, and a system is the antenna, feed line, radios, power supplies, tuners, everything. That can be broken down and loaded into a vehicle and driven somewhere, and then again in a relatively short period of time it can be set up and put into operation. So my interest in antenna supports has to fall into that regime. So I really like trees when they're available, and ropes with a rock gun in that I can throw over a branch. I like PVC poles or PVC pipe that I can join together with couplings and put up. I like the military camouflage netting support poles, and those are seen a lot at ham fests. And they're 4 foot long, and they're about 2 inches in diameter, olive drab of course, and they're rigid fiberglass, and they fit together end to end to make a pole of whatever length you need. 5 of those to give a 20-foot pole is very stable. Again, like I said, that's rigid, and I'll typically guy that from the top. And I like inverted V dipoles because the inverted V only needs one support, and the legs of the driven elements of the inverted V, wire of course, can serve as a couple of guy lines for the antenna, N0EMP.
Okay, very good, thank you. And keeping it on the sort of simple side there as well, I think. Let's see. NY, I think you've probably done a fair amount of this stuff too as well. You want to share any comments with us?
Yes, sir, I do. NYY. That's okay, I'm used to it. Somebody mentioned the trees and the weight in the rope. There's a thing you can buy called an easy hang, which is a wrist rocket slingshot with a fishing or a bow fishing style reel and a sinker. And last time I looked those up, they were about $70. You can buy a wrist rocket at Walmart literally for $3.99. You can buy a Zebco 202 reel for about $4.99, and you can buy 2-ounce sinkers for about $1.50 a bag.
And given about an hour's practice, you can put that fishing line over any tree branch you want. It's amazing how well they work. Remarkably effective. And I have strung a lot of field day antennas and other things up in trees for lifting stuff by using that and some surveyor's twine. Use the fishing line, pull the surveyor's twine back over, let me grab a nickel. Then you tie the surveyor's twine either onto your antenna or onto a heavier rope if that's what you need, and pull it up through the tree. And the cool thing is that with a very little practice, you can get that line to go over or between whichever branches you choose after just a few tries. And I recommend it. Not only do you get an antenna where you want it, but it's kind of fun to play with too. And 0 in my way. Back to net.
Yes, I can imagine playing. I can imagine you playing with that stuff too. Very good, thank you. Okay, I'm just looking here. Terry, how about something from your side of things? I know that you've done a fair amount of tower type work in various conditions, and I would assume a lot of yours is more on the permanent side, but I'm sure you have various other things to share. Would you mind sharing any comments with us?
Yeah, thank you, Kevin. W0ASP here. Yeah, I've done some work with some pretty big iron and a lot of concrete, and I think a lot of that stuff is probably outside the scope of this discussion, unless somebody has a specific comment. But along those lines, I can only say Roan has a wonderful 300 to 400 page catalog that has all kinds of technical information. This is pretty much all you need to correctly put up a tower to specifications. On the portable side, I like to use coaxial fiberglass mats that I buy from a company called Max Gain Systems in Georgia. And these are typically 8-foot lengths of fiberglass with a clamp, a top coaxial clamp on the top of each one. And you stick however many 8-foot sections you want together. You stick it, the first, it that's to be about 10, 12 foot. You push it up in the air and guide the first level. And you get on a step ladder, and then you take the first section, push it up, clamp it down. Take the next section up, push it up, clamp it down. Of course, you have to disperse guy wires along in altitude, but I've used those very successfully in temporary field work, and temporary can be many, many years, although the fiberglass does tend to decay over time. W0ASP, back to net.
Okay, very good. This is N7GES with the NCARC TechNet. Thank you. I've just been picking arbitrarily at various people for comments. So let me now open it up and see if we have other people that would like to add comments or questions about various supporting schemes.
This is November 0, Whiskey, India, Quebec, Carrie in Loveland.
Okay, WIQ, good evening, and go ahead.
Well, on the way to a hamfest, I intercepted a Roan 25 tower, and I insisted on putting it up with a tilt-over base so that I wouldn't have to climb it to bring it down to an antenna to work on the antenna. So that's my main objective. So that's what I had done, and I rebuilt the base, tilt-over base. I got an official Roan tilt-over base for it the last time I rearranged things. So that's it. Back to net.
Okay, any comments or questions for any of these folks or anybody else? It sounds like we have somebody trying to make it not quite strong enough. Try again if you want. Okay, nothing heard. Coming from lack of experience, I guess I have a few questions, especially about the tilt-over or crank-up towers. How stable or secure are these things? I would assume you can still guide them somehow, and I would assume that that's got to be quite a chore when you're then moving the tower from the middle after it has been guyed. How complicated a process is this to set up in a way that you can then move it and do maintenance on it? And that is an open question for anybody to jump in with if they would like to.
This is N0WIQ again.
Go ahead, WIQ.
Well, I planted my tower pretty close to the house, so when I was able to mount it so that it would tip away from the house as I tipped it over. So that is a certain amount of things you have to pay attention to. Now, it's close enough to the house, I could even put a bracket on the house to stabilize it a few feet up off the ground, but I've been using it freestanding for its whole life, which is some 20, 25, 30 years now. Back in it.
Okay, what about crank-up towers? Anybody use those, and how have those been for people?
N0NYY.
NYY, go.
I've had two. I've had a big one that was about 65 feet and a small one that was about 30. The 65-footer was a bit difficult because it was so heavy that it really stressed its cables and pulleys, and everything had to be really set up nicely. The shorter one had a single pulley system, or a single cable. The tall one had a double cable, the short one had a single cable. And the short single-cabled one worked very, very well. It was a little bit wiggly-wobbly until you got it cranked up all the way. I would not have used the small one for a large HF beam or anything with a lot of area, but most of my antennas, most of my tower antennas have been 2-meter, 440, 6-meter, and used just to hold the top end of a V or a dipole or whatever. But you really have to pay attention to the hardware on crank-ups. Physically, they can actually be pretty hard work even with a good winch. But that said, they're hard to beat for convenience. Don't plan to run one partially extended, however, because they get loose and sloppy, and once they start swinging back and forth, they can damage themselves. N0NYY, back to net.
Thank you very much. I'm writing here, so I'm a little slow to respond. Okay, yeah, thank you very much. I'm curious again, and this is my lack of understanding. How does one handle the guys on these various antennas towers that either fold over or extend? Are they fairly easy to pull down and work on and put back up without getting things tangled or messed up or stressing guys too much.
N0 EMP.
EMP, go.
Depending on the height of the antenna and its construction, you only need the guys for wind. So you can put the antenna up and take it down in a no wind or low wind condition with the guys unhooked. And once you put it up, of course they're attached at the top or at some point maybe half, 3/4 of the way up, depending again on the design. But you can put the antenna up without too much wind or no wind, and then if you're going to be leaving it up, you can anchor the guys out, and it'll survive wind in that condition. And then when you go to take it down or lower it, you wait until the winds are favorable, and at that point you can safely unhook the guys at the ground and lower it. Again, that depends on the design and height and everything of the antenna. It's not a universal rule.
Okay, very good, thank you. Bart, you mentioned that most of your work was with, I believe you said VHF, UHF antennas. I guess that's one of the things that I'm interested in doing at some point, is putting up something that I could put additional VHF, UHF antennas on. So I guess what I'm wondering, and I'm also interested in being able to do some of this work myself, so I have been considering like a tilt-over tower. What if I were to do something like that? What kind of tower might I need to consider, size-wise? You know, for several VHF antennas, maybe a 2-meter beam or something of that nature. What might you and others recommend for that?
I would recommend Roan 25, which I think is I hope that's the right number. I think that's the lightest Roan tower you can get. And you can go easily 30 feet unguide. You can go, I think, 40. I had a 40-foot tower that was attached to the eave of the house at about 10 feet off the ground, the very first section. So it was freestanding above that, had no guys at all, and it worked just fine. It had a 6-element 2-meter, a 13-element 2-meter, and a vertical dual band on the top of that tower, and it worked fine forever. Roan will tell you if your wind, depending on what your wind loading is, how high you can go freestanding with their various and sundry tower sizes. I had tried doing the same thing with a mast, but it was going to need a lot of guying, and because I was at the edge of my property, there were directions I couldn't go, and I couldn't keep the mast from swaying too much. It bent back and forth, and I was afraid it was going to throw the antennas off the top. But again, I couldn't guy it properly. So masting is certainly cheaper and lighter and easier to deal with, but you've got to be able to guy it. So if you can, that's a great way to go. If you cannot, then I recommend going with a lightweight tower. And 0 NYY, does that help any?
It does for me. Now, when we talk Roan 25, are we still talking something that could be a tilt-over? Is the tilt-over a separate mounting, a separate part of the tower that you use, or does that involve a totally different type of tower altogether?
N0 WIQ again?
Let me let Bart finish that, and then I'll come back to you, Terry. Go ahead, Bart.
Okay, there's two definitions that we should probably clarify. To my understanding, I reserve the right to be wrong, but a tilt-over normally pivots at some point way above the ground. If you've got a 30-foot tower that pivots at 15 feet, you can swing it down. There's an extra section that runs along that goes up when the top comes down. Where a tip-over tower is a complete vertical solid tower, but it pivots, it's hinged at the base. To do that, you need a bottom section with the hinge pins on the legs. They also make a plate that the bottom section just bolts to. It's like a regular chunk of tower section, but the plate has the big pivots on it. And then you need a base plate under that has the stationary pivot points. And then there's there's 3 bolts, and you take the 3rd bolt out, and the 2 bolts become the pivot point. You can lay the tower down away from the house. I think Kerry mentioned that already. But clarifying the tilt-over, which bends in the middle, and the tip-over, which bends on the ground, I think it's important to separate those. The tilt-over is much more elaborate hardware, probably a little bit easier to use. I've never worked with one myself, but all of the towers I've had up were tip-over, which would pivot on the base in 0 NYY.
Okay, N0 Kerry, WIQ. Go ahead, please.
Now, I have a round 25G tower, which was one of the newer Run 25 towers. And Bart was real accurate, except that the plate you mount on the on a concrete base, and the hinge part comes up off of that, has 3 legs that plug into the bottom of the Round 25 tower, and then you can straighten the tower or put the 2 hinge bolts in or leave them in, however you want to do it. It's easier to put it on the tower if you take that part off there, completely off, and put it on the tower, then bring the tower back over and put it down. But anyway, it's pretty close to the ground. I mean, it's high enough that you can level it. But also the Round 25 tilt-over base uses six studs along each side. And so I had to modify mine because I already had the triad in the ground in the concrete base, so I did a little modification. But on the other hand, it's still the same thing. Taking one bolt out and losing the other 2 so they can tip over, hinge over, and things like that. Now I have a winch on mine, so I can tip it over with a pretty heavy load or pick it up with a pretty heavy load. But that is something else you need to think about, is how heavy it's going to be when you get an antenna on top. Now also I put a rotor in my tower so I can use directional antennas. But yeah, back to that.
Okay, this is N7GES, so I'm doing all the questions right now. I'd like to ask if there's anybody else that has comments or questions at this point, so that I'm not doing this whole net. Obviously, my questions relate to doing something very specific, which is to set up an antenna for I've set up a tower for lighter weight antennas, and to be able to work on it without actually climbing the tower, but to fold it down. However, my next question I'll bring up in just a minute, but I'd like to share the opportunity for other comments or questions, please.
Kilo 50, Colorado boy. On a tilt-over tower, that's the same, like I believe Kerry said, part of it anyway. That's a simple job to do. All you need your 3 bolts and your swivel on one end, of course, and you take only one bolt loose and you tilt your tower over. And man, away you went. Because you leave your swivel on one end there, and that's the easiest way to go, and it does a good job.
Okay, thank you, Mike. And thank you for checking in this evening. W0LEV, I heard you also at the same time.
Yeah, thanks, Kevin. One caution on round 25. I once had, two sections, the concrete base on their own tilt-over base. I had a 6-foot dish LAS mount for 1296 moon bounce on it. And the caution there is if there is much mass at the top of the tower, if you're going to raise it and lower it, you better have at least a 4-to-1 mechanical advantage with pulleys and ropes. It can get out of hand pretty easily. W0LEV.
W0ASP with a comment?
ASP, go ahead.
Yeah, I've had some experience with Roan 25 towers and trying to erect them in primitive conditions where you had nothing but a come-along. And it's absolutely essential to have some mechanical leverage from above ground. You have to hoist this tower into the air from some point 10 or so feet in the air. Even with a winch on a Jeep or something, the forces involved as the tower approaches the ground are really incredible, and they're enough to snap 10,000-pound cable. So you have to be very, very careful of this, especially if you're pulling something in the 50 to 100-foot high range, trying to tip that over. You really need to be cautious of the mechanical forces involved, because they can get away from you, and it's a little bit easier picking it up because you can push it up. You can get some guys and some people, and you can push it up from the ground and get a start. But when you're bringing it down, you can't have people under it waiting for it to drop, and that's where somebody could get really hurt. W0ASP.
Thanks, Terry. I speak from experience. W0LEV.
Okay.
0WIQ along those lines.
Okay, everybody hold up for a minute. Thanks, Dave. Thanks, Terry. Terry. There was somebody else that came in along right after Terry's comment that I could not hear. Come again, please.
N0NYY.
NYY, go ahead.
Terry is absolutely correct, and this gets into a little bit more of an elaborate discussion. I'm not going to try to go there right now during the net, but I will be happy to another time offline. Anytime you get above, I'm going to say roughly 30 feet, and it depends on what you're putting up on the top. If you're putting a monster HF beam up 30 feet, we need to talk about rigging. Seriously talk about rigging. By rigging, I mean how you apply the mechanical advantage, be it an elevated pole, be it a crane, be it gin poles, single or double. Not the gin poles you use to erect the tower sections, but the gin poles used like on a sailboat to actually stand up a mast. There's a whole world of science there, and if you don't pay attention to it, somebody will get hurt. Trust me. The forces can become astronomically huge if they're not applied correctly. As Terry mentioned, when that tower is near the ground, the leverage against whatever's lifting it can be, hundreds to one or greater. Yes, a 100-pound tower will snap a 1,000-pound cable easily. So you've got to plan all that very, very carefully. It's like a bowstring. The leverage when they're trying, put a bowstring is dead straight, and when you pull against the center of it, your leverage against the tips is almost infinite. So, anyway, be happy to talk about rigging. I'm a certified rigger. I'm a certified crane operator, and it can get to be a very elaborate discussion, but there are certainly safe ways to do it, as tens of thousands of hams have demonstrated. N0 and my Y, back to net.
Another comment?
Sure thing. Let me grab WIQ real quick first. Go ahead, Carrie.
Goes like this. You have a lever fastened at the bottom with a weight on the end 30 feet away. And if you pick up or try to pick up the tower in the middle, so to speak, it doesn't take very much weight out there at the end before you start even seeing the tower bow from the weight of it until you get it up to a certain amount of straightness. And I mean, yeah, if you have a 30-foot tower, pick it up at 15 foot, and the ground level is there, so the rest of it is about a 2-to-1 to you're able to pick it up. So what can I say? The rigging, as Bart was talking about, is something you have to give significant thought to, especially if you put a pretty good-sized antenna out there.
Okay, very good. LEV, go ahead.
Yeah, I think the bottom line is those of us who've been there cannot overestimate the forces involved. I think we've all had experience with that, at least those who have spoken about it, myself included, and it is not minor. Even a 4-to-1 mechanical advantage, which I provided with pulleys and ropes when I dropped my 6-foot dish for 1296 EME. It was tough. Don't underestimate. The other comment I wanted to make on a slightly different subject, but it's the same general subject, trade-off between feet line loss and height. Most of us hams who have operated HF like to get it as high as we can. It's not always the best thing on VHF, UHF, unless you're willing to spend a lot of money on the feed line, like 7/8 semi-rigid. 30 feet's good height, but don't use RG58. There's a trade-off to be made between height and feed line loss. W0LED.
Okay. So let me see if I have got you straight there. I don't believe you said that going beyond 30 feet is a bad thing, but it would only be bad if you were using the wrong feed line. Is that correct?
Sort of. The longer the feed line, the greater the loss. If you start out with 100 watts at your station, you got 3 dB loss in the feed line. You got 3 dB loss in your transmitted and received power. Transmitted power is going to be down to 50 watts, and you're going to add 3 dB to the noise figure of your receiver. Just what I'm saying is trade off feed line loss, which is length and choice of feed line, against how high you place the antennas, how high your tower is. W0LEV.
Okay. Can you give me, say, another reference? Say something like, what would LMR 400 be a reasonable thing to choose for another comparison for height reference there?
Well, LMR 400 is a good coax, but it depends on how high your tower is. If it's 70 feet high and you're 100 feet from the tower, you got a problem. There are plenty of online references for feed line loss as functional length, usually posted per 100 feet, and as a function of frequency. I don't have them in my head. RG58's a no-no for any reasonable length on VHF, UHF. Certainly 174 makes a good attenuator. I used it once for just that. Just consult the online references, and I think the ARRL handbook, which every licensed amateur ought to have. It doesn't have to be a recent publication. It's given in there too. Just refer to the coax loss tables as a function of frequency and coax length and coax type. Those tables are readily available. W0LEV.
Okay, thank you. That's what I was looking for. Appreciate that. Any other comments before I continue here?
W3HTL.
That would be Whiskey 3 Hotel Tango Oscar, is that right?
Hotel Tango Lima.
Okay, yeah, good evening. What's the name there again?
Hi, this is Rich and Elizabeth. Good evening.
Okay, yeah, go ahead with your comment, Rich, and thank you for checking in.
Yeah, I had a, comment / question regarding the cable length that we were just talking about. We're using the 400 low loss cable, and you probably heard us talking on here, having some trouble with my dad reaching out, and we're planning on going, at least initially, up to 125 feet to get it over to a taller shop building or maybe up the mountain. And I think I saw that the loss per 100 feet on the 400 was around, I want to say 1.3 decibels. So we're certainly hoping that the better antenna location will make up for any loss we have. I think the antennas we're using are around 8 to 10 decibels of gain. So hoping that the location will make up for any loss we have in that additional cable.
NYY.
NYY, go.
I was looking for the Suffolk. LMR 400 is 2.9 dB per 100 feet at 447 megahertz, just for a reference, and 0 NYY.
Okay, any other responses to Rich?
So that indicates that you are losing roughly half your power. If you start out with 100 watts, you'll end up with 50 transmitted and add 3 dB to your noise figure of the receiver. Really, that's a long run for UHF with that cabling. Personally, I spend the money on a bit more, less lossy cable.
DDZ.
DDZ, go ahead.
Could that figure be counteracted with a high gain antenna?
It could to some extent, but you're still going to lose on receive if you increase the gain by 3 dB. Well, theoretically yes, but best thing you could do for receive is put a switched preamp at the feed point. That's really a long run. And the other thing is, don't believe published gain specifications unless they give you dBi, dBd, or whatever. Or better yet, get the dimensions, plug it into 4NEC 2 or EasyNEC and model a thing. W0LEV.
EMP. EMP, go.
Yeah, if you are in a situation where you're going to have a long cable run, and there's just no way around it, but you're able to run power cables and other cables and Ethernet cables and things like that, but they just have to be a long distance, like hundreds of feet. At some point, it becomes economical to look at remote mounting the transceiver itself, so that the transceiver is at the tower or even up the tower, and what you're running is audio and power and control cables. And there are a lot of radios, amateur radios now, that are getting very easy and inexpensive to remote.
W0ASB with a comment.
ASP, well, hold on just a minute. First of all, OTL, any other questions after all these comments?
No, this is all great information. I sincerely appreciate it. So I'm standing by here listening and considering all the options. W3HTL.
HTL, thank you. I couldn't find it in front of my fingers right at the time. Let's see. ASP, go ahead, please.
Yeah, let's talk about coax loss and the benefits of runs, coax runs versus height trade-off is a very important topic, and all you have to do to experience that is to take a look at any cell phone tower and look at the size of the coaxial cables that they use to feed their 900 megahertz antennas. They are at least 1-inch heliax cables, so much so they're actually considered an important load factor in the antenna design. So, the people that do this for a living take the cable loss very seriously. And, in my opinion, if you're going to be running any more than 100 foot of coax for 440 megahertz or above, you really need to look at something better than LMR 400. There's Heliax and there's LMR 600. But seriously consider it, because the cost benefits will start to make it that you're going to put your antenna out there a long ways away and then higher up, and you're just not going to get any better communication out of it. W0ASP.
I think the bottom line to the model presented tonight, 70 feet tall plus 120 feet run, you really need to look at either remoting or a better coax. Even LMR 400 is too lossy. W0LEV, that's enough for me.
Okay. Thank you very much. This is N7GES with the NCARC TechNet. Thank you very much for your comments. Other comments or questions?
N0WIQ, a question.
WIQ, go ahead.
Well, at one time, NCARC had solid coax running up the tower for their antenna. So it runs in my mind that was even bigger than an inch solid coax. But on the other hand, making a good share of the run with that kind of cabling, although it'd be very expensive, would make a big issue about, or less of an issue about cable loss. And also you'd have to have good antennas so that would eventually get to the point of no loss in the system.
Okay, so I don't think I quite understood your question there. Can you rephrase what it is you're trying to ask there?
Well, I essentially was asking the question of the size of the solid coax they used, because I had the impression it was even bigger than an inch. I just don't know what it was. I was just a member and other people were talking about it, so that's my question, was how big it was.
Sure, you can make 2-inch, 3-inch coax if you want to pay for it. Look under the commercial products and RF or Davis RF. but it gets mighty expensive. W0LEV.
Okay. ZIE, was that you in there?
Negative. Kevin, it's James, KI0KN, and I just briefly wanted to jump in and answer Carrie's question, because I can tell you exactly what each site has. This repeater, as well as the 115, so both Horsetooth repeaters. The main run of coax up the tower is LDF7, which is inch and 5/8 hardline. Heliax, I should say. It's not truly hardline. And which is very low loss and very expensive, about $15 a foot. The buckhorn repeaters have, one of them has half-inch, the other one has the 3/4 inch, LDF4 and LDF5. They are shorter runs, about 60 feet and 40 feet respectively, but the Horsetooth runs being so long, they are the LDF7, the inch and 5/8 coax. So I just wanted to toss that in there to show you what sizes are in use. Carrie is absolutely right. The longer it is, the better the coax should be.
Okay, thank you. And welcome, James. Glad to have you in here. Other questions or comments?
DWC with a question.
DWC, you are very noisy. You might need a bit more power or something, but please try again.
I'm sorry, there's a storm coming over the mountain. My question was, I've heard of a thing called 9913. What is 9913?
It's basically the same as a good grade of RG8, very good grade of RG8.
W0ASP, use that before I get started.
Well, it's braided with both shields.
Okay, everybody hold up, please. We had a huge double. I do need people to please give your call suffix and wait to be acknowledged so we don't have doubles. I think I heard Terry in there first. Is that right?
Oh, yes, this is N0WIQ, and I'm trying to remember what I was trying to say, but 9913 I think is double shielded, although both shields are braided, so like LEV says, a step up from RG8, but it is a little better than RG8, so that's what I used for my first dual band reflector, so it works pretty decently. But on the other hand, now I put in a power splitter and used Roan 25 and on the same antenna, so what can I say?
Okay. Who else came in there at that same time? I thought maybe I heard Terry ASP.
You did, Kevin. Yeah, W0ASP. I've used the RG9913 before, much to my chagrin. It is much like RG8, except that instead of a solid dielectric, it has a semi-air dielectric. There's the dielectric is instead of a solid cylinder with the center conductor in the middle of it, there is a thin dielectric, and then there is a coiled spring-like dielectric that holds the center conductor. So it's a little bit like Heliax, but instead of having the mechanical braces that a Heliax has, it has this sort of half polyethylene dielectric in the middle. And so that does reduce the loss of the cable, and it works fine that way. It's also very, very susceptible to water intrusion. W0ASP.
Okay. All right. Let's see. WDC, does that help? Do you have other questions after all this?
No, thanks. That answers my question. I won't think further about it. I appreciate all you.
Okay. Well, thank you for checking in. You're always welcome to ask questions. Any other questions at this point?
BNK.
BNK, go ahead.
Well, I know that you can use ladder line or window line for long runs with HF. Is it possible to use that same thing for VHF, UHF?
Okay.
Yeah, absolutely. W0LEV, but of course there's a matching issue. When we did Mount Potosi long ago and far away in the June VHF contest, I had a 220 antenna that was totally interconnected with 200 ohm open wire. That used to be the standard before coax came along, W0LEV.
Okay, well, I'm just curious. I watched just because I asked because I watched a YouTube, and this old ham was talking about an antenna and using that, and he said you could run it a quarter mile. So why not use it?
It's fallen out of vogue because it's a balanced line. You have to keep it away from metallic objects, ideally, so on and so forth. Unlike coax, which is very convenient, you don't even think about it. Unless you're concerned with loss versus height, of course. Yeah, open wire is a long forgotten but highly useful form of transmission line.
EMP.
EMP?
There's a very fascinating type of transmission line for VHF. Well, it would work on any frequency, but it wouldn't be practical at HF. But UHF and VHF, UHF, and microwave, it's called a single wire transmission line. And Wikipedia has a great article about it. You have just a single bare wire conductor, but it has to be straight or pretty much straight and away from everything, like Dave said. And at each end you have a conical device called a launcher that transitions from coax to this single wire transmission line. And there's a ham that has done a lot of, he has a web page on it, and I can't remember his name right now or his call sign. He lived in the Napa, California area. Let me reset this. He was about 30 miles away from amateur radio friend of his, but there were mountains in the way, hills, and they used single wire transmission lines and weather balloons to get an aerial antenna that they could talk to each other on over the terrain. And later they experimented with drones. and he's got a real good website, and he's written articles about this, and he just moved to Fort Collins. N0 EMP.
Wow. That's all I can say to that. That's fascinating. Okay, so I assume this stuff is not new. It's been around for a while?
I think probably since the 50s, and it has been used commercially. And what you have is a traveling wave on the surface of the wire, basically. I think Dave knows a lot more about it. This ham that has experimented with it, he was also at our last club meeting.
Well, there you go, Rick. Your mile and a half might actually work. That is fascinating, though. And obviously it sounds like it needs some pretty special care as well. But, you know, if you have long runs, there you go. You work it carefully and strategically to make it work properly. This is N7GES with the TechNet. Other questions or comments?
Kilo 7, Kilo Romeo Uniform. This is Rick up in Drake, Big Thompson Canyon. I just wanted to check in, and Rich is my son. He was asking that question, and yeah, I've got a problem up here with a huge mountain on just to the right out the backyard to the north of me, and a big mountain to the south. So this is all very interesting, and we'll figure out something. We're just trying to get some better signals out for some other repeaters. He's in Elizabeth and wanting to make better contact. Appreciate the net and all the info on here.
Oh, you're very welcome, sir. I think you mentioned your name and I missed it. May I have that again? And yes, I think maybe it was either you or your son that I talked to when you were first sort of getting set up here for communications. Is that right?
Yeah, it's affirmative. I think we've talked to you a couple times maybe, but yeah, we sure did. And it is Rick here and Rich down there. So, yeah, we've got a lot of good information from a bunch of you guys, and really appreciate it. We push pretty hard, and we're going to keep working at it. And at least this repeater works awesome for us 90% of the time. And I've got a antenna up, a vertical up on a 30-foot push-up right now, and it works a lot, real good for local, but trying to get over and around these mountains and trying to just go maybe a couple 100 foot to the south here on a shop building, and maybe even go up off of that and guy it out real well and say if that little bit doesn't change, but we probably will end up with probably 125 foot run a coax. So all this information is good, so we don't do it for naught. We'll try to figure it out before we go all that way, or maybe we won't have to go as high or quite as far. I don't know, but I appreciate all this.
Okay. Well, very good. I'm glad we're helpful. We digressed from our topic, but I think we digressed into an area that was an important issue here, so I'm glad that you found that useful, and absolutely you're always welcome to join us, and I'm as I say, I'm glad you found that helpful. Please don't hesitate to jump in anytime. Okay. N7GES. Anybody else want to add to this topic before I ask another question or two?
EMP.
EMP, go.
Yeah, N0EMP for Rick and Rich up there and their problem. If you are only interested in FM repeaters, it could be real easy to take one of the mobile radios that has a remote head to it. These are designed where you can mount the radio like behind the back seat in your truck or something, or in the trunk of your car, and you've got a cable that comes up to the front for the control head and the microphone. ICOM 5100 is one. Everybody makes a radio like that now that are dual band FM. Something like that is inexpensive, and you could probably run something like Ethernet cable all the way up the mountain to act as an extended control cable, and then you may or may not need a separate cable for the microphone and speaker, but that could be real inexpensive, and that'd be a lot cheaper than Heliax, 300 feet of Heliax and 0EMP.
K7KRU. That's a great idea. I talked to Rich a few ago on the phone. We are going to do some exploring on that idea, and that's actually, we're both running radios right now, like what you're talking, the dual band and the detachable faceplate. Yeah, I would have to run the speaker wire. Boy, that's a great idea. So I am going to do that. Would probably be a lot better than, like you say, the coax and the expense of that and the loss and everything else. So great idea. Appreciate that.
Yeah, I'd use shielded cable for everything, and I'd have ground rods at both ends, down at your house and up on the hill, to ground the shield of the cable at both ends. But it probably work just fine.
Sounds great.
Okay, I think there was a double maybe with Greg. Is there another station there?
WIQ.
WIQ, go.
In terms of support for an antenna, the feed point always has to be supported so it can handle the feed lines. So this is also part of your subject matter. So what can I say? Yes, remote mounted radio, but if you use something like Cat 6 or Cat 6 shielded radio cabling, you would have to be sure that it's long enough and doesn't have enough loss to afford to hamper the controllability of the radio. Also, there's a couple of ways you can remotely operate a radio without cabling too. So, such is life. Back to Ned.
Okay, and that's a good point. And that's something that we might save and talk about at another net, unless somebody has very specific questions about that right now, because that's a whole nother very interesting topic. So give that some thought. Any other comments or questions? And I would open it up to either feed line or antenna support systems, since both of these seem to have been helpful topics here tonight.
KC0ZIE.
There I thought I heard you earlier and I didn't. Go ahead, Darren.
No, that wasn't actually me, but I'm glad James jumped in on that. Two quick comments on remoting the radio heads and all that. A lot of the protocols they use between the radio body and the control head are serial protocols, an RS-232 type signal, which I would be nervous about running more than about 100 feet on, even on good cable. Another product that you might want to look into is something called a remote rig. They're a little pricey, but basically you put a box on each end. You put a box on the head, you put a box on the radio body, and then you run standard network protocols between them, and that's something you can run in almost unlimited distance, set up routers or switches in between if you exceed the 300 feet or so that Ethernet runs. So a couple of ideas there, and back to net, KC0ZIE.
Okay, and once again, what was that last one called?
It's called a remote rig. You just search for it. They make a couple of different products, but that's one of their major ones.
Okay, very good. Thank you. There you go. More options for those that need a remote antenna structure there. Okay. Anything additional added to this? Any questions that all of this brings up?
W0 ASP.
ASP, go.
Hey, Kevin, are you thinking of bringing this remote head operation as another topic, or are we going to continue with this tonight?
I was debating because I think it could be a whole nother topic, but I also don't want to stifle any immediate questions if we've got specific things about, getting a signal to a remote antenna that's too far away for feed line. So, I'm open to suggestions here.
Well, I think it's kind of a can of worms, and a very interesting can of worms to open up.
Okay. Would you like to elaborate a bit more on that?
I mean, well, Darren mentioned getting your signals there, but how are you going to get the power necessary to transmit 100 watts or so without significant line loss? DDZ.
DDZ.
So the remote rig, you would have a box up on top of the hill with the transmitter up there, and the face of the radio and the microphone plug into a box at your place, and then it runs a network protocol between the two boxes. So you're no longer dealing with feed line for the radio. The radio's at the antenna point or wherever you need that to be, and then you're just running a network cable between the two.
Okay.
W3 HTL.
Just a moment. Let me just clarify. Does that then take care of power also, Dave, or is there something else needed to supply power at the antenna end?
There is a protocol called Power over Ethernet that possibly could do that. I'm not sure if the remote rig is capable of power over Ethernet, but you could always get something that would decouple the power and feed the power directly into the remote rig. So, yeah, I do believe it would solve that problem also.
EMP.
Okay, just a second. ASP, any comments back to you, any comments that has generated from you?
Yeah, Kevin, yes, W0ASP. I think you'd have to do something like put a battery up on the remote site and trickle charge the battery with a fairly low current signal, and then let the battery provide the full current that's necessary to operate the transmitter. But I'm just kind of thinking out loud. W0ASP, back to Ned. I'll let you take the other comments. NYY.
EMP.
Wow. Okay, I have a queue going here. We first had HTL. Go ahead.
Good topic. Yeah, W3 HTL, Rich and Elizabeth. Yeah, that's exactly what we were thinking, that we would put a battery box up there with a solar panel to keep it charged. So I think that would probably cover it for us, but any thoughts are certainly welcome.
Okay, let's go to EMP.
Yeah, I'm seeing 4 options right away. Battery box with a solar panel and a charge controller would be one. Battery box with light gauge wire running down to your house and a trickle charger. Would trickle charge over the light gauge wire. Third option would be relatively light gauge wire to run 115 volts up the hill, and then have a switching power supply up there at the radio up on top of the hill. And it would be low current on the 115 volt circuit, so you could still use lighter gauge wire. Or the final option would be real heavy gauge wire running all the way down to your house to put 13.8 volts on from a power supply at your house. So any one of those, pick your poison. N0 EMP.
Okay, NYY.
Well, I would vote for the 120 line up to the top with a good power supply up there. Whether you use a battery backup, that would be neat to have a battery backup up there too. Now you got a big power supply and the battery and the radio and an antenna on top of the tower. So as long as you do the math and keep the weight understood, that would be okay. But there's a reason the power line companies use 70,000 volts or whatever it is, because the higher the voltage, the less the current losses through the wire for a given amount of power. So 120 or even 220 up to your power supply up at the top. That gets my vote. N0 NYY.
Okay. Wow. Lots of good info there. Hope that some of that is helpful. And yeah, we're kind of skirting what I was hoping to cover in another net, and that's okay. If we need to still get into that, we can. But there's lots of good info here. We're almost talking about a repeater, but not doing a repeater's job. In other words, we're setting up a transmitter, a transceiver at a remote location and controlling it remotely. And so I guess in that sense, all of the normal things would apply, getting power to it, controlling it, and all of that sort of thing. So very good information. Any other comments?
W0ASP.
ASP, go.
Kevin, you bring an excellent point that perhaps a remote battery-powered, solar-powered repeater might be the solution for this particular ham that needs to get out with a higher antenna. That'll work.
ZIE.
So I stepped on somebody. I'm sorry. Go ahead.
ZIE with a comment.
ZIE, go.
Thank you. That thought had actually kind of crossed my mind a minute ago, and the question would be for the originator of the question if frequency agility is important, which would mean that you would want some sort of control or remote control of that item. But if a fixed frequency works, then a crossband repeater up there might be a very quick, easy answer. Back to net, KC0, ZIE.
How practical is a repeater with this sort of frequency agility? I guess I might want to ask. Too bad James isn't still here. Okay, interesting thoughts. Good info. Okay, I hate to break away from this, but I did have a couple of extra questions, and we are approaching our 7:30 time limit here. Getting back to supports and things like that, which I almost hate to bring back because we had a whole lot more interest in this other topic. But one of the issues we have is safety, and one of the issues that I had brought up was a tilt over or crank up tower for accessibility to antenna parts. Obviously, there's a lot of very tricky things to consider with a movable tower. So my next question, I guess, and this comes from somebody who has not experienced this at all, only seeing towers in the ground, excuse me, but never above the height that I can reach. What's involved in dealing with a tower you might find at home, which I suppose I'm talking 50, 60 feet or less, especially if one were going to do VHF, UHF type antennas, not your big HF beam variety. How much mast are you going to have to deal with in order to reach when you're at the top? How easy is it going to be to manipulate that stuff? How do you keep yourself as safe as possible? Obviously, climbing gear is probably important, but what type of climbing gear for this type of distance?
KN?
Hey, KN, go ahead.
So I have a couple of comments on the exact towers you mentioned, as I have two of them myself. I just poured concrete last week for my new one. I've got a 45-foot crank-up tilt-over and a 65-foot crank-up tilt-over. And there's a couple of important things to understand about crank-up towers when it comes to safety that are very different than either a guide or a self-standing tower. First and foremost, if it's tilt-over, one of the nice things about it is you don't have to climb. You crank it down and then you tilt it over, and mine are all housing very large HF beams, so I still need a step ladder to get to parts of the antenna. However, it's just a step ladder, no climbing. The most important golden rule about a crank-up tower is that you do not climb them ever when they are extended. The only time it is safe to climb a crank-up tower is when it's completely down and blocked. So it's the best way ever to lose fingers and toes. If you were to ever climb a crank-up tower that was up and the cable broke, it'll slice parts right off of you. So is that kind of where you were heading with that, Kevin? KI0CAN, back to you.
Not exactly, but an incredibly good point. What we had been discussing crank up and tilt overs, and what came of that is the considerations of getting them down and winching and ratio of pulleys and winch material for when you get close to the ground, and height. And so what I was asking was, if you were going to do away with crank or tilt over, what's involved in climbing to and dealing with smaller antennas such as VHF, UHF antennas with a tower that is stationary, 50 to 60 foot, something of that nature.
Well, 50 or 60 feet in a stationary tower, if you're going guide, where it has guy lines back to the ground, you can get away with something easily. Round 25 is plenty. You can take round 25 up to 190 feet guide. So 50, 60 feet guide, you don't need much tower. If it's guide, and climbing it is no different than climbing a 20-foot tower or a 200-foot tower. All the same safety rules and gear apply. As far as 50 or 60-foot freestanding, you can't really go that high freestanding unless you've got one heck of a tower. I'm not even sure round 45 will go that far. You may have to go to 55 or 65 to get that kind of height. When you say what's involved in the climbing and stuff, I guess I'm not sure if I'm missing the point of what you're asking, but it's the same safety rules. I mean, if you're climbing anything over 6 feet, you should have a full harness with fall suppression and hard hat and gloves and boots and all that kind of stuff. Is that kind of what you were after?
Yeah, I believe so. And I was, as I said, I'm approaching this from having never seen a tower above what I can reach. So I know nothing about them at this point in time. I'm asking because I just really don't know. What I guess I'm wondering about is, once you're at the top of the tower, you still have some degree of mast, I assume, that you have to deal with in order to get to the actual antennas. Maybe I'm wrong in that. And so what I'm wondering is, how difficult is it going to be to work on the actual antennas? You're going to be working above your head. Is it easy enough to get to them once you've climbed to nearly the top of the tower? These aren't, just net questions. These are my own questions from lack of observation of what's really up there at the time, so far in my lifetime.
Yeah, okay, I got you now. So, I think there's a fairly easy answer to that, and that is, if your tower is not able to be brought over to the ground or in some way reachable by other means, then you don't mount antennas higher on the mast than you can reach from the top of the tower, or you install a mast that has climbing capabilities. that's very uncommon in ham world. It's more common in a commercial world, but you know, VHF, UHF stuff, there's, unless you're a major, you know, contester or long distance kind of person, there's not a great advantage of mounting your VHF and UHF antennas much above about 30 feet. And 30 feet is very easy to achieve with a freestanding round 25, you know, couple square foot wind load. So once you're at the top of the tower, if you're talking a kind of a typical ham 2-inch round mast, you shouldn't mount things above that unless you can reach them. Now the other option is to use something like a cherry picker, you know, boom truck, something like that, and if it'll reach to the where you want to go, you can park it at the ground and go up in the basket. But as far as mounting things up the mast, for example, my 45-foot crank-up tower, I have a 22-foot mast in that. And my first HF beam is located 6 feet above the tower. There's 4 foot of mast inside the tower, and then I've got a rotatable dipole at the top of that. You cannot, in any way, shape, or form, reach that dipole while the tower is up. So that is why I tilt mine over. KI0KN, back to you, Kevin.
Thank you. That's exactly what I needed to know. I have a better picture. Let's go back just a minute to a previous question. We were talking about remote. I don't think you were here for that. We were talking about remote antenna / remote transceiver situations and how we might do that most easily. The question came up, would maybe a repeater might be a reasonable answer, and the question came up if a person wanted to operate multiple frequencies, not at a time, but switch frequencies, is a repeater practical for that sort of thing? And we're talking for a home station that has geographical difficulties getting out and needing a longer run from the house to an antenna placement. So the question came up: is a repeater might a repeater be a good usage for that? And if a person needs to operate more than one frequency, is that practical?
Well, the short answer to that is no. One of the things to remember about a true quote-unquote repeater is that you have a set of filters called the duplexer that are very sharply tuned to notch out the other signal. So one set of half the duplexer notches out the receive signal from the transmit side, while the other side of the duplexer notches the transmit out of the receiver so that it can share an antenna. And those filters are very sharply tuned, very sensitive, and not practical to be tuned remotely. Is it possible to do stuff like that? Probably. Is it practical? No way. A remote setup would be far more practical. In other words, putting the whole transceiver at the antenna site and linking to it via Ethernet or microwave or something like that. There is some tremendously useful remote QTH software packages out there. There's a whole, as a matter of fact, if I remember right, I think it is remoteqth.com that has an entire open source stack of tools to do exactly that. And it's all the hardware is open source, the software is open source. You can buy kits or pre-built versions of some of it, but that's a far more practical answer than an actual repeater. Plus the fact that if you're doing this, you can do it on, you're not going to get, you know, the repeaters are coordinated, and there are pairs of frequencies designed for repeaters, and you don't want to use those and collide with other ones in the state. So the remote answer via either wire or microwave link is a better answer.
Okay, excellent. Thank you. All right. Any other comments? We're running a bit over. I'm happy to do that if people have the interest, and apparently we've had. I appreciate everybody's indulgence in my own questions here, as this has been something I've been considering. Any other comments about any of our subjects this evening before we close off here?
BBC.
W0ASP.
That for sure. Go ahead.
I'm sorry, Kevin, you got doubled with, go ahead.
Okay. I had just asked if there were any other comments, and I heard you afterwards. I think, were you just alerting me of a double?
No, negative, you got doubled with after that. So I was just wanting to say that we went over a lot of information in this. If you weren't able to write stuff down or remember anything, this is been live streamed on YouTube. So you can go to our YouTube channel, which is available through the NCARC homepage, ncarc.net, and there's a link there to the YouTube page where this net is being streamed if any information was missed. Thank you, Kevin. W0TTZ.
Oh, yes, thanks.
NYY.
Thank you for the reminder, Dave. NYY, go.
Hi, Kevin. I had to step away from the radio for just a couple minutes. Sorry about that. In the last I heard, you were talking about the accessibility of the antennas and a lot of good information there. If one application that I worked on is somebody that was experimenting with antennas a lot, and if this came up, I'll ask. If this came up, I don't want to go over it again, but his technique was a trolley that had wheels about 3 feet apart. A set up at the top of the trolley and a set about 3 feet down, and contained in the trolley at the bottom was a rotator, and there was a collar near the top, and he could put whatever mast he wanted down the collar into the rotator, and the trolley would just run down the side of the tower to the ground, and now your antenna is 6 or 8 feet off the ground. You put out a ladder and you go do what you want to do to your antenna or your rotator. And in just a couple minutes, that trolley could be cranked up or down the tower. Because it was only lifting the trolley and not 3 tower sections, even a very small cable would last forever, very, very long time on it. Had that been discussed yet?
Echo Victor?
Echo Victor, stand by. No, it had not, and I assume this is for lifting antennas or cables or whatever up and down?
Roger. Looks sort of like, the one I saw looked sort of like a grocery cart, kind of hollowed out, but it was just a frame, 4 wheels. The wheels rode on the outside of the tower legs. When it got up to the top, there were blocks that stopped it positively and kept it from moving around or anything at all. Had a latch that would hook it up there, so even if the cable broke, the trolley would stay there until you ran another cable. And you could still climb the tower and stuff if you wanted to, but you didn't have to. You could just lower the trolley back down to the ground, work on your rotator, your cables, your antennas, and then send the thing right back up. But again, this guy did, well, like me, did a lot of antenna experimenting, so it might be 2 or 3 times a day to take the antenna down and change something and put it back up. So this made it ideal for that.
Okay, excellent. EV, go ahead.
Yeah, what Bart mentioned, that's commercially available from Glenn Martin Engineering. There was a ham in Loveland, I don't know his call, that had one. And, up to, on run 25, up to about 50 feet, it worked pretty good, I think. And, you can guy it, and you only let it down, and you drop the guys and let it down on a non-windy day. I've used 60, 70 feet of 25 with VHF antennas where we didn't have wind, and I only, latched on the guys when the wind came up. But anyway, that's one other thing. Let me make sure I've got it. Yeah, I missed most of that. I apologize. I had a phone call, but I'm almost back to what I had in Loveland, which was a 100+ foot guide tower. And if anybody wants to catch me sometime on Simplex and has some questions about how to work on guide towers, I'll let you know my experiences and my mistakes and successes and all that kind of stuff. K0 Echo Victor.
And N0NYY once again.
NYY go.
He had one set of guys at the very top, and he had one set of guys in the middle, and the guy wires all ran to the one tower leg that was away from the carriage. He never had to take the guys down. The carriage could come and go freely, and the guys stayed attached the whole time. Probably could have unguided it and let it be freestanding. I wouldn't have done that with the trolley at the top, but you probably could. But it was securely guided, and the guys just stayed there the whole time through a little creative application. N0NYY.
Okay. Very, very fascinating. All right. I think we'd probably better wrap this up. And I almost hate to, because we've had a good time with this. At least I hope everybody else has. I certainly have. A suggestion for next week, if anybody doesn't have an objection, is weather and its effects on propagation. We talk a lot about space weather, and obviously that's probably, I'm guessing mostly because we're talking about a lot of HF propagation, but local weather is certainly going to affect a lot of our VHF and UHF propagation, probably some of our HF propagation as well. And so if that seems reasonable to everybody, I would propose that would be a topic for next week. Anybody have any objection to that? Okay, that's one time that hearing no response seems to be a good thing. So you be forewarned, that's kind of what we're looking at for next week. I appreciate everybody's comments and responses here. I do hope that others have learned as much as I have. I think it's been interesting, and I hope you found it profitable. Again, we have an Elmer's list, Elmer at NCARC.net. If you have questions, that I think for the time being could be a good place if you want to hear about something or suggest a net topic for TechNet. Send it there, and that's something we can consider talking about, or at least discuss with you personally if you are needing some help on something of that nature. So do take advantage. Don't forget also that the NCARC has its lending library available, and we have lots of good books available. Joe, KD0TYU, is the one you'd want to contact about that, or you can contact any of us, any of the board members, and we can certainly get you in touch with him to find out what we've got. There's nothing better than a good book of reference information. Nowadays we have the internet, but sometimes a book is easier to deal with for some people, and that's available. So please take advantage of that. Let me reset. So again, thank you very much. I look forward to visiting with you again next week, and until then, happy hamming. In whatever area you enjoy doing that. Any comments are greatly appreciated, and thank you very much again. 73, and good evening from N7 GES. The repeater's now open for normal use.
This presentation was brought to you by the Northern Colorado Amateur Radio Club. Thank you for watching, and don't forget to like and subscribe.